Okay, we've been talking about polygons and their angles inside and outside the polygons. We're going to talk about a very specific type of polygon, quadrilaterals, and the first one we're going to talk about are called parallelograms. So first, let's define what a quadrilateral is. A quadrilateral is a polygon with four sides. Now, for it to be a polygon, it has to be a closed figure. It has to have sides that intersect at their endpoints. So it already has to be a polygon, but then now it has to be a polygon with four sides. So these right here, these are all quadrilaterals, and specifically they are polygons with four sides. So they are quadrilaterals. These are not even polygons. They're not quadrilaterals, but they're not even polygons at all. You see that this one doesn't close. This one, the two sides intersect somewhere that's not the endpoint, and then this one has a curve. So we don't even have that. That's not even a polygon. These are polygons, but specifically they're quadrilaterals. Okay, now a type of quadrilateral that we're going to talk about first is a parallelogram. Well, what is a parallelogram? A parallelogram is, now it's not just a polygon, but it's a quadrilateral. So it has to have four sides with both sets of opposite sides parallel. That is what a parallelogram is. So the opposite sides in a parallelogram are parallel. So if you can see in the drawing that's below that there's markings here that indicate parallel. So these two sides right here are parallel, and the drawing also shows these two sides are parallel. So the parallelogram at the right has four vertices. Remember, vertices are like the corners where the sides meet. So what are the vertices? And they are M, the point M, and N, and P, and Q. So what would be the name of this figure? Well, it is MNPQ. Doesn't have to start, it could be NPQM, as long as the vertices are listed in corresponding order. So you can't say P, M, N, Q. They have to go around the figure in order. The opposite sides of the parallelogram MNPQ, just like we named it. Remember, the difference between the name and what the vertices are is the vertices are individual points, so we separate that out with commas. The name has no separations. So what are the opposite sides? The opposite sides are the side NP and MQ, and you also have the other set of opposite sides, and that is PQ and MN. And since it does ask for sides, I should be putting, sides are segments, so I should be putting lines over the top to indicate their sides. The opposite angles, okay, opposite angles, so angles that are across from each other. So here's angle M, and what's opposite of angle M? Angle P. And then also it asks for you to set both sets of opposite angles. So we need another set of opposite angles, and the other angles that are opposite one another, sorry, are N and Q. So angle N and angle Q. Okay. The consecutive angles. Okay, consecutive is one of those words that we used instead of saying same side interior angles. We call them consecutive angles. It's because those are ones that are right next to one another. And there's actually quite a few of them, because if you look first at this figure starting at N, right next to it is angle M. So angle N and angle M are consecutive angles. Okay, so they're right next to one another, but angle M is also consecutive with right next to angle Q. So those are consecutive as well. And we know what consecutive angles are, right? They're same side, so that means that they're also supplementary. So these two are consecutive, meaning they're supplementary. M and Q are supplementary, but Q doesn't have to go only with angle M. It's also angle Q and angle P. And then finally, P could also go with angle N. So that's what consecutive angles are. Those are angles that are right next to each other. Okay, let's keep going. All right, so continuing on, using the same parallelogram, MNPQ, what conjectures can you make about the following? Well, what do you know about opposite sides? Well, we've already said, remember, opposite sides are these right here. Those two are opposite sides. Well, we know that they are parallel. We already know that. But what else appears to be true? Well, the other thing about those opposite sides is they're also congruent. And similarly, opposite, that's a misspelling, opposite angles are also congruent. And if you recall what we were just talking about consecutive angles, and that name, the name consecutive is because the consecutive angles from same side interior angles when we have angle pairs. The consecutive angles are supplementary. So we're going to keep these things in mind, meaning that they add to 180, okay? So I'm going to add that here so that we remember what supplementary means. So here are some conjectures, and we probably already know everything about. We know that if these two sides are parallel in a leaning rectangle, they're congruent as well. And the opposite angles are going to be congruent, and the consecutive angles are going to be supplementary. Also, here's a really important thing about diagonals. It says when polygons have more than 3 sides, they have something called diagonals. What is a diagonal? A diagonal is a segment that connects non-consecutive sides. It joins non-consecutive, okay, I think I said sides, non-consecutive vertices, excuse me. So what that means is B is consecutive with D and B is consecutive with A. B is not consecutive with C, so we can join them with a diagonal. A is consecutive with B, right? There's already a side there. A is consecutive with C, there's already a side there, but A is not consecutive with D, so we can draw that. That's where the name diagonal, that's where it comes from. And you know what a diagonal is. So let's go through this list of things. What are the vertices of this figure? The vertices are individual points, so we make sure that we can separate these with commas. The name of it is starting at any vertex and going around the figure in consecutive. So it shouldn't matter where you start when you name it, as long as you put the vertices in a corresponding order. All right, what are the opposite vertices? The ones that are opposite of each other. Angle A, or I guess it's not the angle, it just wants the vertices. So A and D are opposite, and also B and C are opposite. And coincidentally, the diagonals are named AD and BC. Those are the diagonals. They're joining the opposite vertices. So, all right, let's go to the next one. What is the name of, or what are all the vertices? All the vertices are just listing L, T, O, and S. But what you might want to do is to write out L-O-S-T to spell out lost, or something like that. Can you name it L-O-S-T? No, because that's not consecutive order. So I would have to name it T-O-S-L or L-T-O-S, something like that. Opposite vertices, O and L are the opposite vertices, and T and S are the opposite vertices. So your diagonal names are O-L and T-S. If you were to draw them in, they would look like this. All right, what are the vertices here? The vertices here are D, O, G, S. So I just listed them, and I listed them so I could spell a word. Well, that is okay, but can I name it that? Well, incidentally, they did put these in the order, so I could name this D-O-G-S. The opposite vertices, D and G and S and O. And over here, I might list the vertices as C-A-T-S to spell cats, but can I name it C-A-T-S? No, I can't. I would have to name it C-T-A-S or something like that. And again, the opposite vertices are the names of the diagonals. Okay, so the last thing, or the next thing is to bisect, to make sure you know what the word bisect is. That is to create two equal parts. So if you're going to bisect something, you're going to create two equal parts. So if we say that the diagonals of a parallelogram bisect each other, you have to make sure you know what bisect means. It means that you take the two diagonals where they cross, it cuts each of the diagonals into two equal parts. And I'll show you down here in just a second. So we have 5 properties. Now this is a lot of writing, so get yourself ready. There's 5 properties. Opposite sides of parallelograms are parallel. Okay, that's one of the properties. Okay, and you got to know all of them. You also know that opposite sides are congruent. There's something that you know about opposite angles. The angles, you got opposite angles, and opposite angles of a parallelogram are also congruent. The ones that are opposite are congruent. That's not all we talked about, though. There's another type of angle, and those are called consecutive angles. Well, what do you know about consecutive angles? Consecutive angles are the ones that are right next to each other. They're supplementary. What does supplementary mean? That means they add up to 180. So I'm going to add that in there so that we don't forget. Okay. And then the last thing is what we just added at the top about the bisect is when you draw in the diagonals of a parallelogram, the diagonals bisect each other. So we're going to add that in right here. So these are the 5 properties of a parallelogram, and you have to remember all of them. You have to know all of them. Each time you see a parallelogram, you're going to have to know all of these things are true. You have to know that opposite sides are both parallel and congruent. The opposite angles are congruent. The consecutive angles are supplementary, and you have to know the diagonals bisect each other. So let's look down here. Complete each statement regarding the parallelogram below. Name it. Could I name it A, B, C, D? Yes, I can, and I probably will because it seems like when you name it in alphabetical order, it's easier. The side AB right here is, and this symbol is parallel, so what's parallel is this side right here, CD. Okay, DA, the length from D to A, that length right there is congruent to what other length? Well, yeah, opposite sides are congruent, so CB is congruent in length. Then we've got this angle CDA, so C to the D to the A. CDA, this angle right here. What is that congruent to? Well, that's congruent to CBA. Angle CBA, because they're opposite. And then finally, you've got this little part, DE. Well, what we said was the diagonal, that's part of a diagonal. This diagonal DB bisects AC, meaning E is the midpoint of AC. Also, AC bisects DB, meaning that E is the midpoint of DB. So DE, the length, is going to be the same as EB. It does not mean that all 4 of them are congruent, okay? These 2 are the same and these 2 are the same, but they're not all 4 congruent. And clearly, okay, so anytime you have a problem and the problem does not have a picture, you should always draw your own. So it says if ABCD is a parallelogram, So I drew a parallelogram and named it ABCD. And the measure of angle A is x degrees. The measure of angle D is 2x minus 3 degrees. Find the value of x. Well, we notice that we're given the measure of two angles that are right next to each other. ABCD starts and ends with these two. And right next to each other, those are called consecutive angles. And what do we know about consecutive angles? They are supplementary, so they should add up to 180. So that means if I add x plus 2x minus 3, that should give me 180. So I should have 3x minus 3 equals 180. So if I subtract 3, if I add 3, I get 183, and then if I divide by 3, that should be 61 for x. Again, if you don't have a picture, you should always draw one. So example 5 says XYZW is a parallelogram with diagonals XZ that I drew in and YW that I drew in, and they intersect at point A. Then it goes back and tells you that XA is 3m. So this length is 3m from X to A. And ZA is 5m minus 4. And then YW, that's the whole thing right here, is 10m. Find m. Well, what we know about the diagonals is that they're not equal, but where they meet creates two equal parts. So the 3m is equal to 5m minus 4. That's what we do know. The YW equaling 10m doesn't really help us. It tells us that this is 5m and 5m on each side, but it doesn't help us because they're not equal to any of these. So we got x's on both sides, so let's take away 5m. When you have it on both sides, you take away. So we're left with a negative 2m equals negative 4, and if I divide, oops, I should change colors. If I divide by negative 2, then m is equal to a positive 2 value. Now that would tell us that 3 times 2 makes this 6. 5 times 2 is 10, minus 4 makes this 6, and 10 times 2 makes this whole thing 20. Okay, for each parallelogram, find the values of x, y, and z. All right, so here's number 6. What do we know x is? Well, x is right across from an 80-degree angle, so x is 80. Okay, now we've got, what is that? Y is an exterior angle. An exterior angle. Well, I know that y, since it's outside, is going to make a straight line with whatever's inside. Do we know what's inside? Well, I got to think about that for a second. For me to figure out what's inside, I know that 80 plus something equals 180, right? Because the ones that are right next to each other add up to 180. So this one's got to be 100. So what's y? Well, y is also going to be 80 because together they make a straight line. And then also, if I knew that x was 80, I see that this makes a z, and I probably should have known immediately that those are alternate interior angles, so they're the same. And then finally, z is the same as 100. So here we go on number 7. So I already know what z is because they're opposite angles, and opposite angles are the same in parallelograms. What I was just saying earlier about I should have recognized the z. I see a z right here that has, remember, these are parallel lines in a parallelogram, and here's a transversal. So this angle right here, y, and this angle right here, the 35, those are the same. So this angle y is going to be 35. And then all I need now is x. Well, what do I know about these two angles that are right here that are right next to each other? We know that they add up to 180 when they're right next to each other. So if this is 120, this angle has to be 60. And if part of that 60 is 35, if I've used up 35, I got 25 left. That's where X is going to come in. Okay, let's see on the next one. Do you see again? We're looking for X, and X happens to make a Z with this 30-degree angle down here. So since X makes a Z with the 30-degree angle, X is 30 degrees. And what do we know about those two angles right there? Oh, gosh, this one's pretty tough. How about Z right here? What do we know about those two angles? Well, they are a straight line, so they should make up 180. So if these together make up 180, then if that's 70, then this has to be 110 for Z. Well, what else? What else is 110? This right here is 110, and I've got a triangle that has, it's an exterior. See, sometimes your brain doesn't work. This 70-degree angle is exterior of this triangle. So since it's exterior, it's equal to the two remote interior angles. So 30 and what adds up to 70? That's 40. 30 plus 40 adds up to 70. All right, let's see. Down here in example 9, the last one, the measure of ZWX, that's this angle right here is B. That whole thing is B. And WXY, this whole thing is D. So we have to figure this out. All right, first it says find the values of A, B, C, and D. Usually they give it to you in a way where you could find them in alphabetical order. So here's A. It's the same as this side, which is 15. And we also